Hello everyone, my name is John Magyar, Senior Application Engineer with Altium, and today I'm going to talk about 3D within context of PCB design. Now, over the years I've talked with many customers, prospects, and students about 3D as part of the PCB design process, and a small percentage feel that 3D is really just kind of a novelty, or even a few assert that 3D is just a gimmick. Well, I'm here to talk about some of the details that will reveal the benefits of 3D as part of the PCB design process. So let's take a step back. The PCB is essentially a 3D object which occupies space, and that space is inside an enclosure or relative to other PCBs. So ultimately, a mechanical team very carefully checks for interference between the PCB assembly, its enclosure, or even components within the PCB. Generally, there are many problems that are encountered, and the mechanical team usually has to work in detail with the electrical team to resolve those problems. But what if mechanical problems could be detected earlier during the PCB design process, when the PCB layout designer could easily change them? So I'd like to show you some of the details. I'll go through an approach that uses 3D, and we'll cover modeling, design rule checking, and export of the 3D assembly. So let's take a look at the board. I have here two illustrations. One is the traditional 2D approach, which the designer creates everything in a 2D environment and then exports out CAD files to the mechanical team. And that's been in use for quite a while, and typically the issues that are discovered by the mechanical team have to get fixed, so there's a lot of going back and forth. And the problem here is that between the two component-to-component clearance, there's no way to check that in a true 2D system. And what about enclosure to component interference? The heights are not represented in a 2D model, so there are tricks and approximations that have been incorporated over the years where you can divide the board up into regions and then specify within a given region you can't exceed a certain height. But still, violations that occur would have to be detected by the mechanical team. And that path usually goes back sometimes several times. You get back and forth iterations to resolve common problems. So could be simple component placement, interference, and whatnot. And that's not to say the mechanical team has other more important things to do, such as thermal flow and things like that. So what if these routine placement issues could be discovered early? Now let's take a look at 3D. So by adding a common representation as a solid model, you can give 3D solid shape to your components. And that's done using a format referred to as STEP. And STEP is a common interchange format that's readily available within any MCAD tool. You can work in their environment and export out a STEP model for anything as simple as a resistor and a capacitor component, or the complex enclosure. Anything that can be designed in an MCAD tool can be exported as a STEP model. The designers would then take those STEP models, import those into the PCB components individually, and rule checking can then be done. So now a true component-to-component clearance can be checked, and not only that, the true shape of the enclosure can be checked relative to the true shape of any component on the board. So now any problems that are found can be identified by the PCB designer, and with a simple adjustment of a component or maybe even choosing a different component type, the problem can be resolved before going to mechanical. Now, ultimately, the assembly will still have to be checked thoroughly by the mechanical team. And when you're ready to do that, you can export a full 3D assembly. So not just 2D data goes to the MCAD team, you're actually going to export a full 3D assembly that can go right to an MCAD tool where they can analyze and, if they need to, make adjustments and move components individually. So, in summary, what 3D gets you is early detection of very common mechanical problems. You can detect them early and fix them early before sending them on to the mechanical team. You get a constant runtime rule check where you can always be checking for interference component to component and component to enclosure. So that's always on rule checking. It's dynamic and will detect the slightest violation. 3D export, when you're ready to hand off to the mechanical team, you have a true 3D format that they can work with more easily. So 3D is not just graphics, it's not just a novelty. It provides real value, it's not a gimmick, and can save you time and money. If you have any questions about this topic or comments, drop them in the comment section below, and thanks for watching.